Lesson 8 is on linear equations in disguise, which sounds pretty intriguing, right? Why are they in disguise? But we're going to actually bring back a way of solving when we talked about solving proportions, and we're going to apply it to some more complicated. There's my mouse to work here. Okay, now I have my mouse working, to some more complicated problems. So let's take a look at how we're going to do these. Oh, before, let's remind us of how we solved what was called a proportion. So for example, let's say I had the equation or proportion as we called it before, 5x is equal to 6/12. Now that is setting two ratios equal to each other, which is why we called it a proportion. And remember, there was different ways we could solve it, but the way that always worked was called cross products. And what we did is we circled the ones diagonal from each other. So 12 times x and 5 times 6. And we set them equal to each other. It's called the cross product property. So this simplifies to 12x equals 5 times 6, which is 30. And then we divided both sides by 12. 12 divided by 12 is 1x. 30 divided by 12 ends up being, well, 2.5. 2.5, 2.5, however you want to write it out. So this method here of the cross products, that's what we're going to be doing today to solve our other types of equations. Okay, so again, this method here. This is why it's in disguise. It doesn't look like a linear equation. If I had given you this type of problem back, I think it was in lesson 2, and said, is this linear or nonlinear? You would have saw the x in the denominator, and you would have told me nonlinear. It's actually a linear equation in disguise. So what we're going to do for all of these is we are going to use the cross products property. And but here's where you have to be careful. I'm going to go 8 times 6 plus x in parentheses. If you have a multiple term problem here, expression, you got to put it in parentheses because it's not 8 times 6 or just 8 times x. It's 8 times the whole thing. And that's going to be equal to, then we circle the other diagonal ones, 3 times 7x plus 2/3. Once you do that, this is like a problem we've been working on. Multi-step equation. We're going to use our distributive property and go ahead and solve it. Simplify each side. So again, distributive property. 8 times 6 is 48. Plus sign, 8 times x equals 3 times 7x is going to be 21x. Plus sign, ooh, 3 times 2/3. Don't panic when you see something like this. Sorry, I'm struggling apparently with my arrow. 3 times 2/3. This is really 3 times 2/3. Now remember, we can always put a 1 underneath that 3, and if we cross reduce here, these are all going to cancel out to be 1s. This works out to be just 2. So if you get stuck on something like that, just come off to the side and jot some notes. Because again, this just works out to be 2. Okay, so it looks more intimidating than what it actually is. All right, simplified. This is a problem we already know how to solve. So I know with some of the times we've been working on this, we're struggling about when we want to divide our x terms. Okay, if you get both sides simplified, start with your x terms and get rid of them on one of the sides. I can choose to get rid of this 8x or on the left or the 21x on the right. I tend to like my variables on the left, but in this case, just to show you, I want to actually get rid of the 8. So it's a positive 8, so I'm going to subtract 8 x's. I know that seems weird. I know we want to divide, but we only divide when we're about to solve for the x. Now we're just trying to get all our x terms on one side. So whatever I do to one side, I do to the other. I draw a nice long line underneath, and then I can just bring everything down. I bring down my 48. If I have 8 x's and I combine it with a negative 8 x's, that's gone. 0 x's. No x's. Equals if I combine 21 x's with a negative 8 x's or 21 x's minus 8 x's, that's 13 x's plus 2. Now I have a two-step equation with an x term. So now I'm solving for this x. I have to get rid of whatever's being added or subtracted first. That's the 2. So I'm going to combine that with a negative 2. Whatever I do to one side, I do to the other. That becomes 46 equals, bring down my 13x, because that is 0. And then this is 13 times x. When we get to this point, this is where we divide by 13. 13 divided by 13 is 1x. 46 divided by 13. Well, let's leave it as 46 over 13. You can divide it. It's going to work out to be kind of a crazy decimal here. See, it's some kind of crazy. You could say that it goes in there 3 times if you wanted. That would be 39. And so that would mean if I take 39 out, I have 7 of the 13 left over. That would be okay too. But one of those things we're going to leave. But our focus, remember, our answers don't have to be perfect integers anymore, but our focus is on getting to this point that we know how to do. And we're using our cross products. So let's try one more example. Okay, can this equation be solved? The answer is yes. And I'm just going to use my cross products. And it doesn't matter which way you go first because they're both equal to each other. So I'm going to go 1 times 3x plus 9 equals 7 times 8. Now I'm writing out every single step. Can we reduce the step? Do we need to write the step? No. Okay, 1 times anything stays the same. And you could do 7 times 8. You don't have to write 7 times 8. You could say 7 times 8 is 56. And notice right here, this side is simplified, this side is simplified. And in fact, do we have x's on both sides? Nope, only on one. Now you can go right to solving. So something that looks complicated can actually be a fairly easy equation to solve. I'm solving for my x term, so I get rid of whatever's being added to or subtracted from it, the 9. It's plus 9, so I'm going to do the inverse, the opposite, subtract 9. Whatever I do to one side, I do to the other. I bring down my 3x. This is 0, so I cross it out. I bring down my equal sign, and then when I add these together, I get 47. Now this is 3 times x, so the only thing I have left to get rid of is a 3, so I'm going to divide by 3. Whatever I do to one side, I do to the other. 3 divided by 3 is 1x, and you know what? This one too. 47 divided by 3. That's 15 with 6 repeating, so we could say 3 goes in there 15 times. That's 45, so that'd be 2/3 left over. Okay, you don't have to go this far. I'm good with leaving as 47/3. You could write it as a decimal if it was a terminating decimal, but since it's not, it's always better to leave it like this, then there's no rounding error. All right, so linear equations in disguise, they're actually proportions, or we solve them like proportions. We just need to use the cross products property and then simplify each side and solve for x.